Hi everyone, this is Jaswanth and today we are going to discuss topic electromagnetic radiation from the subject atomic structure. Previously we have stopped near electromagnetic radiation and I have said that I am gonna say you next electromagnetic spectrum wavelength. I have already said about wavelength and we are going to learn more about it. So more topics in the electromagnetic radiation. What is electromagnetic radiation? The electromagnetic radiations which are affected by electric field and magnetic field are said to be electromagnetic radiation. I am going to represent EMR. So we don't need to waste time by writing electromagnetic radiation. That's okay. Both electric field and magnetic field are perpendicular to each other. This is electric field which is straight. We will represent with this thing. It will be straight and magnetic field. If one is like this, another one should be like this. Means like this. This is magnetic field. It will be laying down on the surface. Just to remember. It will be laying on the surface. These rays are perpendicular to each other. For example, let's take this x, y. One is along the y-axis, electric field is along the y-axis, and magnetic field is along the x-axis. Like x and y are perpendicular, same electric field and magnetic field are perpendicular. Okay. Wave theory, corpuscular theory. We have already learned in detail about it. Yes or no? Wave theory was proposed by Huygens. Corpuscular theory was proposed by Newton. What he has said? Different corpuscular sizes, different colors. What wave theory? What Huygens said? Different wavelengths, different colors. Did you remember one point? After Huygens wave theory, corpuscular theory of Newton lost its significance. Did you remember that? After Huygens, they believed that this is the right one. Corpuscular proposed by Newton, it did not explain satisfactorily about the radiation, so they didn't need it. Next, electromagnetic radiation travel in vacuum also. Vacuum also means they do not require any medium. Means we will pass through a prism, we will pass through a glass. We do not require any medium. They can travel also in vacuum. Means in vacuum all the electromagnetic radiations will travel with same speed. Which speed? Light speed. C. We denote it with C. Light speed. What is the speed of light? 3 into 10 power 8 meter per second, or 3 into 10 power 10 meter per second, centimeter per second. These both are very important in the calculation. Means we know it, but meter, centimeter are main. While calculating with angstroms, we should check always this units. If the units match only, we should go to the next step. Otherwise, we will get the answer. That may be right or wrong. Sometimes by taking wrong units, we may get right answer, but not always. Next, after electromagnetic radiation, we are going to discuss electromagnetic. Guess what it is? Spectrum. What is electromagnetic spectrum? In electromagnetic radiations, I have said that they have some different wavelengths. Means each color has its own wavelength according to Huygens. He said about the wave theory. Yes, and that only from that we have got the electromagnetic spectrum. The arrangement of electromagnetic radiations in the increasing order of energy or decreasing order of wavelength is known as electromagnetic spectrum. What is the order? First, cosmic rays. We all know these names but never study about it. Cosmic rays has maximum wavelength. Maximum wavelength. Minimum energy. Now just observe these terms. Next we are going to discuss about it. Minimum frequency. Minimum, that's it, no more. Next, cosmic rays after gamma rays. Gamma rays after X rays. Next, UV rays. Next, visible. What are visible rays? The light which the electromagnetic radiations which we can see by our naked eye, means yellow, green, orange, red, blue, pink, many colors. This all come from the visible region. Next, infrared. IR, I'll represent it with infrared rays. Next, microwave. Next, TV. What is TV? Television. Don't confuse. There is nothing other than this. TV means television. Don't go any more above. Radio. It has maximum energy. Minimum wavelength. Maximum energy means maximum frequency. Just see this. Energy directly proportional to frequency, inversely proportional to wavelength. By going learning more about this topic, we'll get one formula. E is equals to NHC by lambda. Nu is equals to C by lambda. Next we are going to discuss about them only, but we have used the terms wavelength, energy, frequency, so I just gave an idea about it. The very next topic after this are about wavelength, frequency, all those. Visible rays, what I have said you. We can see with our naked eye. Did you know this? Understand this order? Whip jar, the rainbow colors. Means there are many colors in our crayon box, but these are the main colors which from these colors we make more by mixing, by the combination of some colors. By going front, the wavelength increases. Wavelength increases means energy decreases. Inversely proportional here. This has more energy. Minimum wavelength. Going in front, this is the condition. Now, what are the wavelengths? Mainly in problems we discuss about these wavelengths. UV, visible, IR. About cosmic, gamma, X, they won't ask. UV rays. What is its range? About wavelength 380, 3800 angstroms or 380 nanometers. Both are same, 380 nanometer. For visible, it should be greater than 3800 angstroms and less than 7600 angstroms. Red has the most frequent wavelength. That's why red, green, yellow are these the lights which are used in traffic. Red, this can be seen through far length, means we are far distance from the traffic pole. But then also we can observe these colors. So they use this red, orange, okay, anything. Next, visible after infrared. For infrared, let us make a box about it. Some important means it has two different infrared, near infrared, far infrared. For near infrared, wavelength should be greater than 7600 angstroms and less than 20,000 angstroms. And for far infrared, they should be greater than 20,000 angstroms. Big zeros. 20,000 angstroms. If it has a wavelength greater than 20,000 angstroms, then it is said to be a radiation coming from far infrared. So, yes, you may get a doubt. Why we can't see these rays? Yes, why we can see only visible? The meaning is these can be seen. So they get visible rays, visible radiations. These rays, we know that there is one blanket, atmosphere, blanket of blanket of air which surrounds the earth is known as atmosphere. It surrounds our earth by to protect the ultraviolet rays and some harmful rays from coming from sun to the earth. It protects that. That's another topic. These rays we can't observe, but they are present in nature. That may be on earth, that may be or not present on our earth, but they are there which we cannot see. These are the only spectrum. These are the only radiations which we can see. Means many colors we know, but they all come from this. They seize the origin for them. Next, what is wavelength? Did you remember this? We have stopped just near wavelength. We have discussed about it and stopped it. That's okay. What is wavelength? The distance between two successive crests or two successive troughs is known as wavelength. Very simple. Crest means the curves above the graph are known as crests. This is known as crest. And below, troughs. The distance between two successive troughs is known as wavelength, or two successive crests is known as wavelength. Simple. Next, frequency. I have said you about it while discussing about electromagnetic spectrum. Now let's know about it. The number of waves passing through one point in 1 second. For 1 second, the wave will be going on like this, like this, like this. For 1 second, through one point, how many waves means like this, how many times it has passed. This is a point. From this, how many waves has been passed. That is known as frequency. Nu is equals to c by lambda. What is c? Speed of light, 3 into 10 power 8 meter per second. Units derivation also we can do. Meter per second, unit of c, and meter, unit of lambda. For this we have not discussed unit, right? Unit of length is unit of wavelength, but it is so small, so we use angstroms, nanometers. 1 angstrom is equals to 10 power minus 10 meters, or 10 power minus 8 centimeters. It is so small, so to not describe it by using powers, we use the symbols like angstroms, nanometers, decimeters, decameters, centimeters, more like that. But the main thing is unit of length is equals to unit of wavelength. And while doing problems, remember that you have converted angstroms into meters or centimeters if it's needed. Next, here say 1 by second means we does not represent like this. We do not represent like this. We use second power minus 1 or cycles per second or hertz. These are the units of frequency. Next, wave number. The number of waves present in one unit length. For suppose some unit we have taken 1 meter. Imagine, okay, 1 centimeter. 1 centimeter. In this length, how many waves are present for a particular time? How many waves? For calculating that, nu bar is equals to 1 by lambda. For 1 unit length, how many waves are present? Means what is lambda? Distance between two crests and troughs. So we Do 1 by lambda and find nu bar, that is wave number. Or if you don't want this, reciprocal of lambda A, wavelength is known as nu bar, simple. Next, amplitude. The height of crust means this one, or depth of trough, this one, is known as amplitude. What are units? Meters, centimeters? No. We just say that height of crust or depth of trough, but we do not use units to represent it. We had a relation of it with intensity. Intensity directly proportional to amplitude square, capital A. I directly proportional to A square. Okay. Time period. The time taken for completion of one wave means one wave should go like this. How much time you have taken it? Come on, say me. What you will do? T is equals to 1 by u. What is nu? Not u, nu. C by lambda, and T is equals to lambda by C. We can also represent like this. Nu is equals to C nu bar. Is this clear? Next, about energy. What energy? E directly proportional to, I have said that E is equals to NhC by lambda. We are going to discuss about it in next class. Just remember this. We are going to discuss in detail. That is very important topic in atomic structure. Energy directly proportional to, frequency directly proportional to, nu bar directly proportional to 1 by lambda. Why? E is equals to NhC by lambda can be represented by E is equals to NH nu. E is equals to NHC nu bar. NHC nu bar. E directly proportional to nu bar. E directly proportional to nu. E inversely proportional to lambda, because if lambda increases, energy decreases. This is the relationship. These are also same. Nu directly proportional to lambda. These all are constant. C is always constant wherever you go. 3 into 10 power 8 meter per second. Not only on the earth. You go to Mars, Jupiter, Moon, somewhere. But 3 into 10 power 8 meter per second. This is not like gravity. Okay, that's not needed now. Nu inversely proportional to lambda. Nu 1 by nu 2 is equals to lambda 2 by lambda 1. Or nu directly proportional to nu bar. What is that? Wave number. Nu 1 by nu 2 is equals to nu 1 bar by nu 2 bar. Means to calculate directly when the given values. Means I will discuss about this in problems. Just I am saying now. To directly know. Otherwise, if the given values lambda 1 angstrom and C we know that, and lambda 1 this, lambda 2 is equals to 2 angstroms. What is the ratio between nu 1 and nu 2? What you will do? Nu 1 by nu 2 is equals to C by lambda 1 by C by lambda 2. C cancelled is equals to lambda 2 by lambda 1. Why this all? This one there no. Nu inversely proportional to lambda. Nu 1 by nu 2 is equals to lambda 2 by lambda 1. Finish. Same like this and then next. Wave number inversely proportional to lambda. We know that. Nu 1 bar by nu 2 bar is equals to lambda 2 by lambda 1. For calculating or for doing problems, we had some formulas or tricks or anything. In your language, what you will say, you can say energy in electron volts is equals to 12,400 by lambda in angstroms. If they give you value of lambda, E is equals to NhC by lambda. This is the universal formula. For anything we will use this formula. Okay. If they give you lambda in angstroms, 1 second. What is the value of H? 6.63 into 10 power minus 34 joule into second, or 6.63 into 10 power minus 27 erg into second. Because 1 joule is equals to 10 power 7 erg. We know this, no problem. Yes. If they give you lambda in angstroms wavelength, No need to convert into meters or centimeters and substitute these values and multiply it with C 3 into 10 power 8 meter per second. No need this all. 12,400 by the given value in lambda. Substitute. You will get the electron volts. For suppose if they ask you in units, represent the energy, value of energy in erg per atom or in ergs. What you will do? Erg per atom, kilocalorie per atom, kilojoule per atom, mole. They will ask you what you will do. Just use. Means you got 2 electron volts. 1 electron volt means asked in kilojoule per mole. 96.45 kilojoule per mole. Then what is the energy of 2 electron volts in kilojoule per mole? You will calculate what is energy 2 into 96.45 kilojoule per mole. That's it. Finish. Means to reduce our calculation, you have to remember this too. This also you have to remember. Let's do some problems and we will discuss some problems in the next class. The energy of radiation is 4 electron volts. What region does it belong? What is this question? Did you understand? I given some wavelengths for some regions for like UV infrared. They asked what region does it belong? Given energy in electron volts. 4 electron volts is equals to 1400 by lambda in angstroms. Can we use this? Yes. Otherwise we have to substitute all. 3100. Lambda is equals to 3100 angstroms. Means, now where it is? Can you guess? It's in UV. Why? No special answer for this. Less than 3800 angstroms. 3100 angstroms is less than 3800 angstroms. Means this radiation electron volt in electron, this radiation is coming from ultraviolet rays. Very dangerous. Okay, next one. Calculate energy of a radiation having wavelength to 24,800 angstroms. Calculate. What will happen? 12,400 by 24,800 angstroms. 0, 0, 0, 0. 124 ones, 124 twos. 0.5 electron volts. According to the units asked, we can convert. Next, same similar question. Energy is a calculate energy. Do we need to convert this into angstroms? Do you think like that? No need. Simply we will turn this. Means 1 angstrom is equals to 10 power minus 10 centimeters, right? Let's send 1 10 power minus 1 up. What will happen? Energy in electron volts is equals to 1240 by lambda in nanometers. While we had the 1240 by lambda in nanometers. 1 second. Now it will be clearly visible to everyone. Let's calculate. 1240 by 500. 262s, 225s. No need. 62 into 4. Do we need this calculation? Yes, for sure. 2.48 electron volts. Same thing. Convert into units which they asked in the question. Okay, this is the thing what we have discussed today. What we have discussed first? Electromagnetic radiation. Right? Next, electromagnetic spectrum. Next, characteristics of wave. This is a simple topic to understand, but coming to the calculations, questions, they will be a bit complicated, but on practice they will be simple, no worry. In the next class we will discuss some problems on this, some models I will cover, and photoelectric effect, Planck's quantum theory, black body radiation, there are many. Let's cover them too. I have covered to the NCERT also, but we have to read once again because that is very important to write any competitive exam. Okay, let's discuss BBR, means black body radiation, in the next video. Thank you.